Hey guys, happy Wednesday. Go ahead and put everything away that you have out and get out your math notebook. And we are starting the dreaded fractions.
Yeah!
I know. Guys, they're not a big deal though. Okay, we're gonna take our time. Okay, we're gonna do one day at a time and it'll be fine. But you guys have to be open-minded. Okay? You can't when Mrs. Long tells you or I tell you it's math time, oh my gosh, it's so hard. How do you even know it's hard before we even get started? Okay? If you go into it negatively, you're already going to be struggling. Okay? You have to go into it with the right mind frame that it's fine. I'm going to take my time. I'm going to use what I learned, use my notes. If I need to rewatch a video, I will. And we're just going to get it done. All right? I do have for you guys lots of videos and songs today. You guys know I love Math Antics. I think he's a better teacher than I am. He's way better entertaining. Oh, you guys are so nice. But I think he's super entertaining, and I love the way he teaches. So we have a couple Math Antics today. We have our Number Rock song. We've got some vocab. Okay, we're going to take our time and just one day at a time. To go ahead and get us started, we have 3 vocab words for your math notebook. They are fraction. Go figure. We're starting fractions and you're going to put the vocab word fraction. Numerator and very good, denominator. So these 3 vocab words in your math notebook. I know I heard some friends, oh, I did this last year. I remember. That is awesome. If you guys remember what you guys started learning on fractions, awesome. And hopefully this day is just a review for you. So you may use your iPads, look up all 3 vocab words, give me a definition. You could even give me an example. You can see on if you need to. Mason, you have a question?
No, I don't.
Oh, okay, perfect. Malia, did you have a question?
No, I'm trying to see it.
Okay. Fraction, numerator, and denominator in your math notebook. One more minute. All right, raise your hand and tell me, what is a fraction? What is a fraction? Max?
A fraction is a part of a whole number.
A part of a whole number. Good. Anybody have anything to add to that, Mimi?
A fraction is a tiny part of a fraction or something is a tiny part of it.
So it's a tiny part of something bigger. Good. Mason?
Can I give an example?
You may give an example.
2/8.
Alright, so 2/8. So we have our fraction bar in between them. We also can write our fraction bar as this. Add that in your math notebook. Your fraction bar can go either way, and it means the same. What about numerator? Ben?
It tells the top number of the fraction.
Good. So if I'm using my example of 2/8, circle the 2. The 2 is our numerator, the top number. So if the numerator is our top number, the denominator is our? So also write down 2/8 and circle your 8, the bottom number in your math notebook. Amy, have anything to add about numerators and denominators? Mimi?
Enumerator shows how many top number of fractions shows how many parts we have.
Good. So the numerator shows how many parts that there are as far as, depends on the fraction. If it's 2 slices of pie out of 8 slices of pie, so that bottom number is how many you have altogether, right? And the top number kind of depends on what you're talking about. Like I said, if you're talking about maybe pizzas, how many pizza slices did you eat? Well, I ate 2 pizza slices out of 8 slices altogether. Bradley?
The number above the line in a common fraction showing how many of the parts indicated by the denominator are taken.
Very nice. I have 2 vocab words I want you to add. Improper fraction. Oh, my handwriting's getting messy. And mixed number. Improper fraction and mixed number. Go ahead and also look those up on your iPad. Improper fraction, mixed number. Bless you. Improper fraction and mixed number. Raise your hand and tell me, what is an improper fraction? Sophia, what's an improper fraction?
A fraction in which the numerator is equal or greater than the denominator.
Okay, good. So my numerator is larger than my denominator. So in the example here, 9/8, okay? Typically in a proper fraction, our numerator is smaller than our denominator. So an improper fraction would mean that my numerator on this one, they made it larger than my denominator, okay? We don't like seeing improper fractions. Normally we would change them, and we'll learn how to change them later, but we're going to change them to proper fractions, where, like this one, is a proper fraction, 2/8. My numerator is smaller than my denominator. What about a mixed number? What is a mixed number? Justice?
A mixed number is a whole number in a proper fraction that represents each other.
Good. So a mixed number is a whole number with a proper fraction. So, for example, 2 4/5. That would be an example of a mixed number. I have a whole number of 2, and I have a proper fraction here of 4/5. Okay, here's an example. You don't often hear people calling fractions proper fractions. Most of the time, if somebody just says fraction, like 2/8, you're assuming that it is proper. Okay? You hear improper then if it's incorrect with having the numerator larger. Okay? But most of the time, it's just applied that a fraction is proper then. All right, any questions on our vocab so far? All right, ladies and gentlemen, these should be in your math notebook, and we are going to dive into some math antics. I think these math antics videos are going to be videos that will be hopefully just a review for you. This part of the fractions should be what you learned in 4th grade, but it'll be a nice refresher for us to kind of see it again because it's been a long time since you've seen it. Okay? So sit back and please just be a good listener and watching and paying attention. Nothing else should be out. You shouldn't be working on anything else. Pencils are down then.
If you've been learning math for a while, then you probably already know a thing or two about fractions. And if you've ever had to break a cookie in half to share with a friend, well, then you've used fractions in real life. Oh, well, thank you. That's because fractions are used to represent smaller pieces or parts of things. When you're first learning about fractions, it can help to draw pictures to see how they work. So let's start by drawing a circle. Now this circle represents what we call a hole. Now, not the kind of hole you can fall into, more like a whole cookie or a whole pizza. Now if we divide that circle, or whole amount, into 4 parts, then we call each of those parts a fraction of the original whole circle. Because this is math and not art, we can't just keep on drawing pictures. We need to learn how to write out fractions using the language of math. Yep, you guessed it. That means using numbers. Unlike a regular number, to write a fraction you need 2 numbers. One number on top, one number on bottom, and a line between them. I'll explain exactly what the line's for later in the video. But for now, let's figure out what those 2 numbers mean. Remember, fractions are used to represent parts of something. And the number on the bottom tells us how many parts that something is divided into. The number on top tells us how many of those parts we have. For example, let's write a fraction for our drawing here. I divided the circle into 4 parts, right? So the number on the bottom will be 4. And I still have all 4 of those parts, so the number on top will also be 4. I have 4 out of 4 parts. That means I still have a whole circle. But what if somebody came by and took away 1 part from the circle? Well, the circle's still divided into 4 parts, so the bottom number would still be 4. But I only have 3 of those parts left. So that means the top number will change to 3. So I have 3 over 4, or 3/4 of a circle. Make sense so far? Good. Let's try another example. Let's say that I divide a rectangle up into 8 parts, and I give you 3 of those parts. Since the total number of parts is 8, the bottom number will be 8. And since you have 3 of those parts, the top number will be 3. So the fraction I'm giving you is 3 over 8, or 3/8 of the rectangle. No need to have. Oh, and it's important to remember that for fractions to work right, the parts that you divide the whole up into have to be equal. We can't take a candy bar and say, well, I'm going to divide it into 2 parts, so this is your half, and here's my half. Let's look at a few more examples so you can really see the pattern of how fractions can represent parts of objects. This rectangle is divided up into 3 equal parts. and 2 of them are shaded red. So 2 over 3, or 2/3 of the rectangle, is shaded red. The circle is divided into 12 equal parts, and 7 of those parts are shaded green. So 7 over 12, or 7/12 of the circle, is shaded green. The hexagon is divided into 6 equal parts, and 5 of those parts are shaded blue. So 5 over 6, or 5/6 of the hexagon, is shaded blue. Alright, so you can see how fractions can be used to represent parts of objects like circles and rectangles, but fractions can be used for more than that. They can be used to represent parts of, well, anything, like pets, for example. Let's say you have 7 pets, 4 dogs, 2 cats, and a big fat hamster. Well, that means that 4 over 7, or 4/7 of your pets are dogs, and 2 over 7, or 2/7 of your pets are cats, and 1 over 7, or 1/7 of your pets are hamsters. It also means that your house probably smells like a pet store. Okay.
Alright, I want to pause there because in your math notebook, I want you to write down a fraction representing your pets. If you don't have pets by chance, that's okay. Write down the fraction of pets that you would like. Malia, will you try my left light, please? Okay? No questions right now. How many pets you have. And you can combine if you want to say all the pets, or if you want to give me a fraction saying I have how many cats I have out of all of my pets. Okay, you be creative with your fractions. For me, my example is going to be, I have, of course, horses. I have 2, and I want you to label your fraction. I have 2, and I'm going with horses here. 2 horses out of all of my pets, which is, hold on, I have to think for a minute here.
30.
Shh, you distracted me now. Shh, no numbers. Out of 17 is all animals.
I have 16 at all.
You got chickens too?
I have chickens, yeah. So chickens, that's 9 right there, okay?
I knew it.
I've got chickens and a bird and goats and a bird. Yes.
I got 2
Cats. All right. So I want you to be creative, and I want you to give me a fraction representing your pets. Like I said, if you don't have pets, be creative and give me a fraction of pets that you would like to have. Maybe when you're an adult, that's what you're going to have. Okay? Be creative. So I have 2 horses. Out of all of my animals is 17. 2/17. Out of all of my animals, 17, 2 of them are horses. All right, you be creative. So your bottom number, what is all of your bottom numbers going to be? Represent? All of your animals. You pick which animal you specifically want to talk about then and tell me how many you have. Okay?
This morning, my dog, she went in my neighbor's yard, and she pooped in their front yard right when they
goodness.
were pulling out.
Oh, okay. Well, that's embarrassing.
But they have a
Your dog
too.
pooped in the neighbor's yard in front of them. All right, 1 more minute. Hands down, 1 more minute. I'm going to give you guys a chance to share. I know you guys want to share this fraction, don't you? You guys are excited, I know. You make your fraction however you would like with your animals. All right, ladies and gentlemen, I want you, because you're really excited to share this fraction, I want you to turn to a neighbor, and I want you to tell them your fraction of animals that you did. Make sure you tell them what is your numerator represent, and what is your denominator represent. You may turn to a different neighbor and tell a different neighbor your fraction of pets.
2 cats. 3 dogs. I have 2 dogs. I have 2 dogs, 6 chickens. Can I do 2 cats?
All right, listening in 3. Listening in 2. Listening in 1. All right, an example from Mrs. Long. Ready? Mrs. Long has one cat out of 2 animals that she has all together.
She must got a dog too.
She has a dog
Yep.
too. Yep. So she has
so
one
smart.
cat out of 2 animals all together. Her animals, so she has 2. All right, ladies and gentlemen, take a breath. 3, 2, and 1. I know we really liked talking about our pets, and we want to share lots about those, but we're gonna continue on. All right, lights, please, Malia. Take a breath, guys. Relax. Back to being a listener.
So fractions can be used to represent anything from parts of a circle to kitty cats. Did you know that fractions can also be used to represent things you can't even see? Well, like a test score, for example. Let's say you take a math test and there's 20 questions on the test, and you get 17 of those questions right. That means that you got 17 over 20, or 17/20ths of the questions right. All right, so that's the basic idea of how fractions can be used to represent parts of things. But there's a lot more to fractions than that. In the next section, we're going to be looking at some of the other things we can do with fractions. But before that, let's review. Fractions are used to represent parts of a whole. Fractions are written in the form of a top number over a bottom number with a line between them. The bottom number represents how many parts the whole is divided into, and the top number represents how many of those parts you have. And finally, the parts that a whole is divided up into must be equal for fractions to work right. To really understand how fractions are used to represent parts of things, be sure to do.
All right, ladies and gentlemen, we're going to continue on. He's going to continue talking about parts of fractions. And, of course, he's using his example with his cookie and candy bar still. He loves food just as much as we do.
I thought he ate it.
Now that we know how to use fractions to represent parts of a whole, there's a few different things we can do with them. First of all, we can compare fractions. Comparing fractions means checking to see if one fraction is greater than, less than, or equal to another fraction. That's pretty easy if we think of fractions as parts of objects and draw pictures to help us see what we have. Here's an example. Which of these fractions is greater, 3/8 or 5/8? To answer that question, let's start by drawing 2 rectangles and divide them into 8 equal parts. Since the rectangles are divided into 8 parts, each of those parts is called an eighth. Now, let's shade 3 parts of the first rectangle, or 3/8, and 5 parts of the second rectangle, or 5/8.
All right, so looking at this fraction then, which fraction is larger, 3/8 or 5/8? Hannah?
5/8.
Why 5/8?
Because they shaded it in more squares.
Good, it has more shaded in. Okay, so each of the eighths, each one of these little squares, it has more shaded in. How many little individual squares do they each have? Justice?
8.
They each have 8. Good.
Our picture makes comparing these fractions easy. You can see that 5/8 is greater than 3/8 because more of that rectangle is shaded. Okay, now let's try one that's a little harder. Which of these fractions is greater, 3/4 or 4/5? Well, let's start it.
Ooh, is that one as easy to see which one is larger?
Kind of.
Kind of, because on this one, I would assume this one has 4 shaded in, but this one only has 4 parts. My denominator, that bottom number, are they the same on this one?
No.
No, so this one's going to be a little trickier. It has an extra challenge to it.
With 2 rectangles, but this time we need to divide them up differently because the fractions we're comparing have different bottom numbers. The first rectangle will be divided into 4 equal parts, and we'll shade 3 of them to show 3/4. The second rectangle will be divided into 5 equal parts, and we'll shade 4 of them to represent 4/5.
Now, ladies and gentlemen, if you're using pictures to help you on fractions, I'm totally okay with that. Remember, whatever helps you to get the correct answer. However, if you are going to be using pictures like this, shading in parts, you would have to actually use a ruler to make sure that you shade in each of these squares has to be exactly the same, okay? Just like he showed on the candy bar, I couldn't have one little piece here and then this next one's really big, okay? You would have to use a ruler and measure each of your squares out to make sure it was exact, okay? So something to keep in mind if you want to use drawing to help you with fractions.
Now to compare, all we have to do is see which rectangle is shaded in the most.
Oh, so which one is larger now when he's showing us that comparison? 4/5. Good.
And that tells us that 4/5 is greater than 3/4. There, that wasn't so hard after all. All right, let's try one more example. Let's compare the fractions 1/2 and 2/4. Again, we start by drawing rectangles and dividing them up into parts. 2 on this one and 4 on this one.
I want you to tell me. Give me a thumbs up if you think 1/2 is larger.
No.
Give me a thumbs up if you think 2/4 is larger. I had lots of you do nothing. Oh, I had a couple people say 2/4, and then I had a couple people say that they're equal.
Next, we shade the parts of the rectangle according to our top numbers. 1 on this one and 2 on this one. Now, all we have to do is compare. Well, what do you know? The
Very
same amount
nice.
of each rectangle is shaded. That means these two fractions are equal. It might seem strange that two fractions can have totally different numbers and still represent the same amount, but they can. Fractions like that are called equivalent fractions. Equivalent fractions have different top and bottom numbers.
That is going to be a vocab word, but we're going to add that in our notebook for tomorrow.
Are equal in value. We'll learn more about equivalent fractions later in this video, but for now, let's find out what else we can do with fractions. Another thing we can do with fractions is add them together. Any two fractions can be added, but for now, we're only going to add fractions if they have the same bottom numbers, because those fractions are much easier to add. Like these two fractions, 1/4 and 2/4. Let's add them together. Again, we can use drawings to help us solve this problem. Looking at the rectangles for these two fractions,
So he said the same bottom numbers, but we're better than that. What are those bottom numbers called? Oh, not numerators. Good. Denominators. Okay, denominators.
We are better than that.
You're better
we
than
can
that.
add them visually just by rearranging the parts. Because all of the parts are fourths, our answer will also be fourths. We can just take this 1/4 from over here and combine it with these 2/4, and ta-da, 3/4.
So what did you notice about that denominator? Did the denominator change? The denominator stayed the same. It stayed the same because they were already both 4s, okay? This would not have worked if I had one of 4 and one of 5, okay? They both have to be the same. So he is not his numerators, though. What did he do with the numerators? He added them. 1 plus 2 to get 3. Good.
So 1/4 plus 2/4 equals 3/4. Let's try another one. Let's add 3/8 to 5/8.
You tell me that answer.
Ooh, he's 11. 5/8.
3/8 plus 5/8. My denominator, is my denominator going to change?
No.
My denominator is going to stay the same. Good. My numerator, 3 and 5, what do I do with those? I add them to get 8. And I did hear a couple people say a whole, because 8 out of 8 is going to be, if I ate 8 slices of pizza out of 8 slices,
It's gone.
I ate the whole thing, it's gone.
That's a lot of pizza.
Which is very likely. I could do that. Okay? So I ate the whole pizza. It's a 1. I ate 1
And we can use
pizza.
any shape we want, so I'm going to use a circle this time. So we have 3 out of 8 here and 5 out of 8 here. Just like our last problem, we can add these by combining the parts. So let's put these 3 over here with these 5. And, well, what do you know? That fills up all 8 sections. So 3/8 plus 5/8 equals 8/8, or 1 whole circle. In those examples, you might have noticed a pattern. The bottom number of our answer was always the same as the bottom numbers of the fractions we were adding. And the top number of our answer was just the sum of the top numbers of those fractions. Well, that's how it works. That's the procedure or set of steps for adding fractions that have the same bottom numbers. That's important, because if you can remember that procedure, then you won't need to use drawings to help you add fractions. And that's a really good thing, because what if you had to add these two fractions together? 1500ths and 1000ths.
Oh, that'd be hard to
It would
draw,
be way
right?
too much work to draw rectangles and divide them up into 100 parts. Fortunately, since we know the procedure for adding fractions, we can do it without the drawings. First, let's write out the problem. Now, because we're adding fractions, we know that the answer will also be a fraction. The bottom number of our
And your math notebook. Write down this answer. 1500ths plus 1000ths. What is going to be your answer? Write it down.
So it will be the same as the bottom number of the fractions we're adding, 100. And the top number of our answer will just be the sum of our top numbers, 15 plus 10, which equals 25. So as you can see, adding fractions with the same bottom numbers is easy when you know the procedure. All of this brings up a really important point. When you're first learning about fractions, drawing pictures and imagining that fractions represent parts of cookies and candy bars can be really useful, and it can taste good too. Thinking of them that way can help you understand how simple fractions work, and it can even help you solve some basic math problems. But soon, you'll have to do harder math problems, and to solve those, you'll need to stop them